Hello everyone, welcome to your day 2 Python workshop. Sorry for the delay. Davis is unfortunately not able to be here, and were supposed to have another person, but he's not here. So this is our day 2 for the Python workshop. And so last time we left some homework for you guys to do. Has anyone done the practice? If not, we can just go over the solution for each of the problems as well. If you have done or have not done the practice, just type it in out in the chat so we can so I can take a look. Oh, okay. I guess I'll just go over the solution. Okay, yeah. I guess I'll just go over the solution to make sure that at least we have like understanding of how to solve each of the questions. You tried 13. Okay. And did you like successfully do it, or was there like a problem? Oh, you did it. Okay. Okay. So I'll just go over all of the solutions each individually. So let's go to Dmod. Again, CC13, J1. Oh, all wrong. Okay, that's fine. Okay, so let's read the question together. So, you know, a family with 3 children, their ages form an arithmetic sequence. The difference in ages between the middle child and the youngest child is the same as the difference in ages between the oldest and the middle child. So, for example, their ages are 5, 10, and 15. So what does this mean? This means that, so let's say if the difference between the middle and the youngest child, which is 5 and 10. So basically over here, the difference between the two children are 5. The age gap is 5, which means that the difference between the middle and the oldest child should also be 5. So see, since both adjacent pairs have a difference of 5 years. So given the ages of youngest and middle children, what is the age of the oldest child? So again, we'll get input, we'll get 2 numbers. So the first one is the age of the youngest child. The second one is the age of the the middle child. So basically for this question, it's pretty straightforward. We get 2 inputs and we are supposed to output the age of the oldest child. And we know that the age gap between the youngest and the middle child is the same as the age gap between the middle and the oldest child. So if we just go back over here, so this is our solution for the last times. We'll just do it. So first of all, we have the youngest child. So we type in something like young equals to, and again, for input, remember how we said for input to Python, we just do input. But again, remember how we have to cast it into like an integer, because we're taking 2 integer numbers as input. So 12 and 15, these are 2 like numbers. So I have to cast them as integers. So we have one input as young, and then we have another one which is the middle child. So middle equals to same thing, input. Then finally we need to get our output. So first of all, how do we get our output? So first of all, we have to calculate the age gap between the middle and the young child. So all we have to do here is middle minus young. We get the age gap. And then finally, we have to get the age of the old child. So we do old. And since we know the age gap already, we just have to do middle plus old, as that will give us, middle plus gap, as that will give us the age of the oldest child. And finally, all we have to do is have to print it out. I have to print old. So print is how we do output in Python. So hit run, and we copy the first sample input. We get 18, which is correct. And we test the second one. Hit run. We get 10, which is also correct. So now all I have to do is I have to go to submit solution. I'll copy my code, then go to Python 3. And we submit. Oh, that's what you did, but it showed that it was wrong. Do you want to? Can you share me your code? Just like send your submission into the website. So if you like over here after you submitted, you can see on the top left, there's a URL. You can just send me that URL, then I can take a look at the source code for you. But yeah, basically this is how you would approach this problem. It's pretty straightforward. Um, there might be some syntax error like that. Like for example, you didn't cast integer. That's a common issue. The calculation should be pretty straightforward. And then yeah. So if you have something that came out wrong, then if you send me the code, I can take a look at it. Okay, while we're waiting for the solution, I'll just go on. While I'm waiting for the code, we can just go on to the next problem. So that's CCC 16J1. Tournament selection. Each player in a tournament plays 6 games. There are no ties. The tournament director places the players in groups based on the result of games as follows. So if a player wins 5 or 6 games, they're in the first group. If player wins 3 or 4 games, they're placed in the group 2. And then if a player wins 1 or 2 games, they're placed in group 3. If a player does not win any game, they're eliminated from the tournament. So write a program to determine which group a player is placed in. So the input consists of 6 lines, so we have 6 games. Each will either win or win or lose. And then the output will be 1, 2, 3 for each of the 3 groups, and then -1 to indicate that it has been eliminated. So this is also a pretty straightforward question, except this time it'll be we'll be using if statements. So again, first of all, 6 inputs. So we can just do, I'm just for simplicity's sake, I'm just gonna put like game 1 equals to input. And notice how for this time for input, we don't have to we don't really have to cast it because we're taking the string input. But just for like consistency, I'm going to still have the string input here. And then all we have to do here is to just do that same thing 6 times, except that we change the variable name so that they're not duplicates. So now we have taken in 6 lines of input of whether the person won the game or not. And then lastly, we have to keep a count of how many games he's won. So we have to do a count variable that start with 0. Oh, he sent in a code. Okay, I'll take a look at it after this problem. So first of all, obviously we have to evaluate whether the input is is a win or a loss. So all I have to do here is if game 1 equals, I think Python should be equals. So if game 1, again, remember the equal sign means we're evaluating whether the 2 values are the same. So we're evaluating if this is a W, so if this is a win, then we do count equals to count plus 1 because we're adding 1 onto our count. That's a valid syntax. Oh, this should be right. So and then if we didn't win, so if it's a loss, that means we don't have to do anything about it, because if it's a loss, that means like if the total games won should be like remain unchanged. So we don't need the else if statement that checks for the loss. And I don't know why it's giving me a syntax error, but we can just go back and fix it later. So again, we have to do this 6 times. So we each with the second game, third game, fourth game, fifth game, and sixth game. And then finally, we have to check which group it ends up in. So this is where we use extended like else if statement. So if the count is, so first of all, if it's 5 or 6, so if it's equals to 5, so again, the OR operator, or equals to 6, then we know that it is placed in group 1, so we print 1. Or the count is equals to 3, or it's equals to 4, then we print 2. Sorry, no semicolon. Or if the count is equals to 1, or the count is equals to 2, we print 3. And at the end, if there's nothing, that means the person is eliminated from the challenge, so we do -1. I still don't know why there's an error here, but we'll just run it. Oh, sorry. Python should be semicolon. Completely forgot. Well, again, this is an example of like a syntax error because I'm too used to writing code in another language. So I just kind of automatically just did that. I think or operator is. Oh, I think it's in Python it might be just called or. Sorry, sorry for the confusion. So yeah, or basically means that as we talked about last class. Let me just open the slides for the last time. So yeah, what does it mean? So brackets shouldn't be used between lines because it's not really a thing in Python. But that was something from Java. But for the or operator, um, where was the slide? Oh, I guess we didn't really talk about it last class. Okay, so basically, oh, it's right here. It's logic operators, as we learned last class. Basically those double lines means or, but that's not in Python. Don't do that because that's not a part of Python. So basically, or returns true if one of the statement is true. So basically we're just checking if it equals to 5 or if it's equals to 6. So if it equals to one of them, that means we will do the that means it will return true. So if it at least equals to one of them, then it will basically evaluate to true. And there shouldn't be brackets either because yeah, complicating the code. Okay, this should be good. So if we copy the first sample input, we get 2, which is correct. And then if we copy the second sample input, we get -1, which is correct. So now we can submit our solution. Again, Python. Yeah, so we get all correct. So again, sorry for the confusion. The brackets, there shouldn't be brackets. I was writing like C++ code, but this is basically how you would solve this problem in Python. And let's take a look back at the solution from AppNeat. So that was for CCCJ CC13. Let's take a look at the solution. Yeah. So basically how yeah, so your logic is definitely correct. Your logic's right. But basically how this works, how kind of like the judging system works is that these two are just example input and outputs. So like there are basically just like an example of what might happen if you are given these two inputs. But realistically, like you're basically it's the compiler, I mean the judge, is judging you against a like unknown set of like data. So basically it will give you like completely random numbers for the example input. They will not give you 12 and 15. It will give you some random numbers. So you have to do that based off of like again the input that it gives. So that's why you have to do the input function at the beginning. So that but like your code can adapt to like multiple different like data values. So that means you can just it'll be really easy. Yeah, basically like you can just like you have to write the logic of the code so that whenever like no matter what value you're given, your code will process and give out the right like the correct answer. So that's why your code didn't pass because you were yeah, what we did is you just did the sample input, which but your logic is completely correct. Your logic is completely correct because you did the age gap and then you did the oldest child. So yeah. So does anyone have any questions on the CC16 problem? Does anyone have any question on the tournament selection one with the code? If not, we'll be moving on to the next review, the last review problem. Okay, I guess we'll be moving on to the next last problem. So last problem is CCC 20J2. 20. Epidemiology. People who study epidemiology use models to analyze the spread of disease, blah, blah, blah. When a person has the disease, they'll infect exactly R other people, but only on the very next day. No person is infected more than once. We want to determine the total of more than P people that had the disease. Oh, so we want to determine when a total of more than P people has the disease. There are 3 lines of input. Each line contains one positive number. The first line contains the value of P. So P is we want to test whether the total is more than P. The second line contains N. The number of people who have the disease on day 0. The third line contains the value of R. So R is how many other people that it will infect on the next day. So I'll put a number on the first day on which the total number of people who had the disease is greater than P. Oh. Okay. So this will be using basically our for loops. So again, if we look at the slides here, because this is a repetitive task, you're supposed to iterate through every single day of possibilities. So basically, okay, so let me just summarize this question real quick. So basically, you're given a value P, so 750. So you're supposed to know when the people who are infected with the disease are surpassed 750, right? Is it surpassed or is it equal to? Total, yeah, a total more than P people who have the disease. So you're supposed to check when your total number of P surpasses 750. And then you're supposed to output like on which day it will surpass that. So if we start with one person, so this is on day 0. Right, it's on day 0. Yeah, day 0. So on day 1, we have the value R. That means he will infect at least 5 other people. So that will be 1 plus 5, right? So because the one person's already infected, and then the 5 people will be also infected. So that means that becomes 6. On day 2, this will become 6 plus 6 times 5, because again we have already the 6 people who are infected, but then we also have the new 30 people who they've each infected, because each of them can infect 5 people. So that means we have now 6 times 5, which is 30 newly infected people, and now there become 36. So now on day 3, we have 36 plus 36 times 5, which in this case, let me just pull up the calculator, is 36 times 5, 36 times 6, so 216. So that's on day 3, but it's still not surpassed 750 yet. So on day 4, we can have 216 times 6. So on day 4, it becomes 1296, which at this point is definitely bigger than 750. That means we have our answer, which is number 4. So on day 4. So this is basically how the problem works. And let's code a simple solution for this. First of all, we're taking 3 integer inputs. We have the P value, we have the N value, of the R value. So we're not going to use these values as names because it's pretty confusing. But so P is the criteria that we're supposed to meet. We'll just put, for example, criteria. how do you start with 750? I mean, 750 is basically 750 is the number that we're supposed to check against. But we want to determine when the total of more than P people have had the disease. So basically, this is like just check. This is like a baseline. This is like a bar line of when we have more than this many people who are infected with the disease. So think about it like if you think about it as a graph, 750 like for example, 750 is our target. This is 750. So we're supposed to it's asking for when we will hit our target. So on the first day we have one person. Second day we have 6 person, and then we have like 36. And then we keep growing until we surpass the until we surpass 750. So basically 750 here is just like basically just checking when you will have more than 750 people who are infected. Does that explain the yeah, okay. Sounds good. So and then the next number we have is the starting number. So we will just say uh the infected. Again, by at the start, the infected number will be 1. And then lastly, we have how many people I can infect. So how many people, what would we call a spread? So basically, this is how many people it will spread each time. And in order to find a solution, we're asking about the day of which the disease becomes surpass the criteria. So also have to keep track of a variable called day. So we start at day 0 because right now we start at day 0. So how will we do this? So we can either use a for loop or a while loop, but in this case, a while loop actually makes more sense. So again, our the while loop again is really straightforward. The syntax is basically the same as the if statement, except that it will repeat itself. So we'll just do while. So again, while. So we're trying to make the number of infected people bigger than criteria. So we'll end when that happens. So while not infected bigger than criteria. So while the number of people who are infected is not bigger than criteria, while we are not reaching this case, what am I? Sorry, I always have brackets as a habit. But so while this condition is not met, that means we will go in and then updating all the values. So first of all, we update the infected people. So every day the infected people becomes the infected people plus the spread times how many infected people there are. Right. So basically, because every single day, so we already have this many people who are infected, but we also have this many people who are joining the infected group. So this is the basically our first line of input. Then we have to keep track of day, right? So we have to do day equals day plus 1, because we're keeping track of the day so that we will when we're out of the while loop, we will have our correct answer. And lastly, we just have to print out the answer, because when this while loop breaks, is when we will have more people who are infected than the criteria. That means by that time, our day will be the correct answer. So we input this problem, we get 4, which is correct, and then we copy this one to get 5. Oh, we didn't get 5. That's weird. So well, it should be 3. Leaving on day 0 with the disease. Days after all the people are infected. Um, hmm. 2, 3. This is weird. There's actually 2 people on day 2 with disease on just other day. There's actually 2 on each other day. Oh, it says they infect exactly our other people, but only on the very next day. Hmm. On the very next day. What does it mean very next day? Okay, let's read the explanation for output because I think I might have confused the sample as well. So one person on day 0 with the disease affects five people on day 1. On day 5, exactly 25 other people are infected. So one person on day 1 affects 5, 5, other 5, 25, 125. Oh, oh, sorry. So basically, if we start with one person on day 1, it will infect 5 people on the next day. So we have 6 people, but this person will not infect anyone anymore. So yeah, again, the first they will only affect people on the very next day. So that means it will only affect 5. It will affect one person. So it will affect 5 people, and then those 5 people will infect another group of 25 people, which will be on the total together. That's 31. Right. So yeah, basically only the people who are newly infected will infect more people. So like yeah, they will only affect people on the very next day. So they will only infect people for the day after. After that day, they're no longer like contagious. So they will no longer infect any more people. That's kind of where our problem went wrong, with our program went wrong. So instead of doing this, we'll keep yeah, so instead of doing that, we have to keep let me think. Yeah, so we have to keep up with a value that basically says how many people were infected the day before. So that's the day before. So again, the day before equals infected, because at the beginning, at day zero, uh, day before should have the same number of infected as the infected, because how it works is at day 0, I mean obviously the person who can infect people is, so at day 1, the people who can infect people is the first ever person. So we write our code a bit. So now our infected becomes the spread times day before, actually. But then we have to update our day before to become spread times day before. Mhm. Yeah, so this should be the next line. So again, if this is confusing, so basically how it works is let's say we have day 0, we have 1%, right? Or infected. So right now this is our infected value, and this is our day before value. So on day 0, they're all the 0, 1, 1. On day 1, we will update so that our infected value is, sorry, our spread value is 5. So on day 1, I'll calculate this. So infected equals to infected plus spread times day before, so that becomes 6. So again, our infected values still remain the same, but we times our spread. So now instead of being 1, our day before value becomes 5. So and then we update the day value, day number. So basically, we know that the previous day, five people who got infected. 5 new people got infected. So on day 2, when we do this again, we calculate the first line, which is the infected plus spread times day before. So now this is 31, which is correct. We're going the right track. But our day before becomes 25 because only 25 people who got infected. So basically, that's how the logic works in this case. And now it should be correct. That is 4. This should give us 5. Yeah, correct. So we will just submit the solution. Yeah, and it's all correct. So does anyone have any questions for this problem? If not, we'll be moving on with some review first, and then we'll be probably taking, yeah, we'll after review we'll do a little break, short break, and then we'll go back. So review from last week's stuff. So this thing is I pretty much reviewed all of these by doing the problems, but again we have if statements. The last time we talked about if statements, again, if some condition, then we have the colon. Then we have an indentation, again, very important in Python because the indentation tells the program where your code is going to be, and it will just print out welcome to coding class. Else if statements. So again, I've already demonstrated else if in in the little problem that we did. So basically else if is if the first condition doesn't pass, we will go into the second evaluation. So if B is not bigger than A, that means we'll go into evaluate if A equals to B. And the else statement is just basically at the end catches anything that isn't caught by the preceding conditions. So if it doesn't go into any of the preceding if evaluations, then it will just go into the else evaluation. And how do we use while loops? And again, I just demonstrated in the last problem. While loops basically same thing as if statements, except that it will just run this thing on repeat as long as this condition is true. So as long as this condition is true, we'll be continuing running the loop. What is the plus sign for? Which plus sign are you talking about? Is it this one? This one, okay. So the plus equal sign is basically so if we go back to our previous day's slide, our plus equal sign should be in the assignment operator. Not here. Yeah, plus equal sign. So over here you can see our plus equal sign. So this is the assignment, these are the assignment operators. So basically this plus equals to 3 basically is the same as x equals to x plus 3. So you're just increasing that value by 3. Same as all of these other operators, if you see them down the line, they just basically mean the same thing as the thing. Like this is like, oh, minus itself by 3. Like the time multiply itself by 3, divide itself by 3, mod itself by 3. And then this is like root itself by 3, but you don't have to worry about that. This is like square itself by 3. So not square itself, raise it to the power of 3. But again, you don't have to worry about those. For now, I don't have to worry about the plus equals to, which just increase it by 1. For loops, again, for loops are like I guess the harder ones. So we will be using the range function. So range returns you values, so starting by 0 and then ending and increasing by 1, and then until the end number. So again, range of 6, like we discussed last time, it equals to 0, 1, 2, 3, 4, 5, and it does not go into 6. Does not go into 6. So the real end number is actually 1 less, exactly. So for the following code prints numbers from 0 to 5. So again, we will have 0 to 5 over here with the print function. And then we can also indicate where it starts and where it ends. So again, this is basically the same thing. These two are the same. So we'll also print out 0 to 5. What are strings? In Python, strings are sequences of characters. So basically strings, again, we've used them multiple times. It's basically a line of text. It can be like a word, it can be a sequence, it can be a sentence, it can be however many characters you want. So in Python, strings are sequences of characters. They're just any symbols or numbers. Strings also a data type, just like integers are data type. And strings are, yeah, really useful in coding assignments because oftentimes you will have to store a sentence or a word or numbers that you will need to use later. So strings is a very important concept, and it's basically it's just data type as well. How do we use strings? So again, double quotation marks is the important part. So anything that's defined inside a double quotation mark will be viewed as a string. This entire thing is a string. So anything, yeah, and double quotation mark will be viewed as, and you can put anything in there. You can put like, you can put hi, you can put comma there, you can put symbols, you can put dash, you can put numbers, you can put like unique different like brackets, whatever, plus, minus, multiple. Like all of these will be viewed as a string altogether. So will be viewed as a text, as a part of a text. And again, if you want to print out a string, all you have to do is reference the variable, or if you want to print out hello by itself, what you have to do is you have to have the double quotation mark here, and you have to put hello. So that's basically how you will print out stuff in Python. Notice how we can for integers we can just print 3 because 3 in itself is an integer. So this will be printed out as 3. But we also do this, which has no real difference. It'll still print out 3, but instead this is printed as a string type. It's printed as a integer. Slicing. So what is supposed to be, so basically slicing is also an important part. Basically just it's like a substring. So you're taking a part of a string. So slicing is when you refer to a small section of a string. Slicing occurs in this format, s square bracket start end. So the end index is not included. So again, it's like the range function. If we specify like 0 to 3, it'll only give us 0 to 2. So again, same thing here. If we get 1 to 3, it will actually only return us 1 to 2. So in this case, we'll get EL as our output. So you get EL as our output. And again, this is like the same thing as indexing. We talk about indexing. So again, everything in coding start at 0 and at like n-1. So I think we talked about it briefly last class, but just a reminder, the first letter, the index for it is not 1, it's actually 0. The last letter is obviously like 4, it's not 5, it's 4. So again, indexing the index of the first letter is 0, the index of the second letter is 1, the index of the third letter is 2. What indexing? Indexing basically means the positioning. So the positioning of the H is at the index 0. So the position of the E is at position 1. So L is at position 2. This L is at position 3. This O is at position 4. And don't really worry about the negative signs below. Those are like more advanced techniques. But for now, just memorize how to do indexing. And also how do we find the length of a string? So sometimes it would be useful to find out how long a string is. So all I have to do is just the length function. So again, lang, and then you put in like a variable, whatever. So again, lang, let's say of hello equals to 5 because we have 1, 2, 3, 4, 5 characters. The lang of let's say thigh is equals to 4. So yeah, that's pretty straightforward. Check string. So this is also something that's really useful and it's only in Python. So you can check if a certain phrase of a character is present in the string. We can use the keyword in or not in. So all we have to do here, we have to like basically just we're given a sentence that's this long, and we're checking if the letter combination AIN, if the AIN is inside the sentence. And if we print out check, that means it will just say true. Because again, this is the condition. This entire thing is a condition. It will output this is a boolean. It will output as true or false. And here's a cool kid. If cool kid is in X, we put Yes, we print no. So again, this output will actually give out yes or no because we're evaluating with the if statement. But in the cell, this part of the code still evaluates as true or false. So again, it's a pretty straightforward function. It just checks whether something is inside something. That's literally that's basically it. And the combining strings. The combined strings is actually pretty straightforward. You just use the plus operator. So in this case, we were combining hello and world. So our output will be hello world. And notice how there's no space here because we did not put any spaces in here. So it just basically tells you, oh, we're combining the word hello and world, but we didn't put any space in there. If you want to put space, what you have to do is you have to do a plus like you put like a little space in between and then plus b. So this will be I'll put you hello world with the correct spacing. So again, plus sign you can use for combining to combine strings. There's some additional methods. So lower method will return the string with all lowercase letters. The upper method will return the string with all uppercase letters. It's not really useful. It's not really used a lot. But again, you just do for this one, you just have to do the string variable thought lower or upper, depends on what you want. So it's not really useful, but it's there for you to use. The strip method return basically removes any white spaces from the beginning and the end. So if you have hello world here, like notice how there's a space at the beginning and the end. So if you do the a dot strip, you would just like remove these white spaces here. There's no more white spaces. And the replace one replaces a string with another string. So the replace function basically it will iterate through the entire string. It will find out where there are h's, so it will replace all h's with j's. So that's why it becomes this jello world. I guess we'll do a final like demonstration problem. So rotating letters. So this is basically dealing with strings again. Our artist wants to construct a sign whose letters will rotate freely in a breeze. In order to do this, you must only use the letters that are not changed by rotation of 180 degrees. I, O, S, H, Z. Basically, X and N. So basically, these letters, it's like just some simplicity's sake, it's just saying that, oh, if we flip it, it's still the same letter. Try to forget that reads that word and determine whether the use can be used on a sign. So I'll put yes if the input word can be used on a sign, otherwise I'll put no. So basically all you have to do here is you have to check if the entire sign is, if the entire word is combined, is a combination of these letters. If it's not, for example, in this case, E is not flippable, that means we output no. We output yes or no. And that's really simple. So first of all, we have to get in the input word, get our word as an input. And then we have to, all I have to do is have to check each letter in the string. So for this question, our in will be really straightforward. Will be really useful. So again, we have our this is our flippable letters. So we have our bank of letters. So the letter is equal to, so again, I, O, S, H, Z, and then X, N. So these are these are the acceptable letters. And now we have to check, make sure that every single letter in this word is one of these letters. So all we have to do is we have to run a for loop. And for this for loop, we'll have to run how many times? Let's see. We'll have to run through each letter in the string. So in this case, I don't think we talk about how to do that. Not really, we didn't talk about how to do that. So let's take a look. So let's go back to the for loop slide. So for x in range of this. So again, we'll be using for x in range But this time our range will be the length of the word. So because we're iterating through the entire word, we just do this. And then we'll have to pick out each word, I think. So we'll have to make sure that every single letter in that word is one of these letters. So we have to keep track of a lag. So again, by default, let's assume that everything is true. Let's assume that this entire word is a valid, is a yes. This is a flippable letter. And whenever we see a letter that's not flippable, we will actually change the flag into false to indicate that the word is not flippable. So our logic is pretty simple. If the word at the index is not in letters, so it's not one of these letters, that means we have to init. We know that it's not flippable. We'll do flag equals to false. At the very end, let's just check if flag is true. So if flag, then we output yes. Else, we output no. We run this. We get yes as the first output. Oh, we get no as the second output. So again, our program should work if we submit it. And again, just to we pass this. And again, just to reiterate, so this thing over here is basically indexing. Again, it's picking the square bracket is picking out that specific location, the letter at a specific index. So again, so let's recap. It range from length of word. So we know that, let's say if we have a word called SNHIS. So we have this word, we know that the length is actually equals to 5. So we know that a range function will give us 0 to 4. And again, we know that the indexing for a word that's 5-letter long is 0, 1, 2, 3, 4. So we know that this will iterate through all 5 letters because we do the indexing here, which starts from 0, indexing starts from 0. So we conveniently, we just have to do word X, which will give us the specific word, the specific letter at the index. And yeah. And now we'll take I guess 5-minute break. We should be good. So yeah, we'll return at 11:33 and continue with the rest of the lesson. So if you have any questions during this time, you can feel free to ask in the chat and I'll try to respond to every question. For now, we'll take a 5-minute break. Okay, we'll get back to our slides. So first of all, we'll talk about a list. So a list is a really useful item that you should like. It's called a data structure. It's a very used data structure where you can store multiple values in a variable, and this is really handy. It's probably one of the most used data structures, one of the data structures that's most used in coding. So it's basically a group of similar information under the same name. So it's like a to-do list, basically. You have a list, let's say, you have a list of strings as a to-do list. So basically, it's like what things you have to do today. You can have a list of numbers, you can have a list of strings, you can have a list of booleans, you can have a list of you can have a list of decimal points. You have a list of anything. But again, it stores multiple values in a variable and basically groups them together, and that's also same as string indexing. So what the list looks like in Python. So for example, this is our to-do list. So again, see how we initiate it with the square brackets. We also end with the square brackets here. And then we have commas in between each individual variable. So we have 3 strings over here. We have log on to computer, comma, join Zoom call, comma, learn about Python lists. So we have the 2 commas, which basically you need to have commas in between each variable or each data to make sure that they're connected. This creates a to-do list that creates 3 strings. So you can also, if you want to, you can also have them on separate lines, which might be easier to look at because Python doesn't care about spaces. So because they ignore white spaces inside of lists. So we don't have to care about a lot about indentation in this case, but again, they have them like this. And in Python specifically, the elements in a list don't have to be the same data type. So for example, you have a list of 2 integers and a string. This is valid because we have integer or 2 integers. Sorry, we have 1 integer, we have a float, and then we have a string. So again, decimal points, remember how it's floats, all floating point numbers. So we have an integer, a float, and then a string. We have 3 different types of data in Python list, and this is acceptable. How do we access elements in the list? So again, it's the same thing as our string. So indexing. So again, our logon to computer in this case will be 0 index. So in Zoom call will be 1 index. And learn about Python list will be 2 index 2. So again, it counts from 0. So the first element is the 0th index. So if we do print to do at 0, again, use square brackets in this case over here. So you have a log on the computer at 0. So you output 0. Log on the computer. Then if we put to do at 1, we'll output to join Zoom call. Again, pretty straightforward. And again, if anyone has any question, feel free to interrupt or just say in the chat at any times. You can also access multiple elements through the use of list slices. So again, same thing as Python. You just basically slice apart. You take a part of the list out. So in Python, you do it with the square brackets and the colon. Same thing with sorry, in the string, you do the square brackets and a colon. Same thing with the list. So in this case, we have a list called L. Then we want to get from 1 to 3. So again, 0, 1, 2, 3. This is the indexing. From 1 to 3, we'll start at 1, we'll end at 2 because we don't count 3. So we get 2 and 3. So if we do this, is basically if we don't put anything in the front, that means it will default to start at the end. Same thing, if we don't put anything at the back, it will default to go all the way to the end. So this is realistically 0 to 2. So again, 0 to 2 was cover 1 and 2 because it doesn't include 2. So 0 and 1. So we have 1 and 2. Then for 2, basically this is equals to 4. So this is equals to 5. Because it's going to the very end. So 2 to 5. So we start at the index 2. We go to 3. So we get output as 3, 4. And then we print this. 2 colons. Essentially what this does is I'm pretty sure this is taking every 2. Let me start up blank defaults to the first one. This is, I think it's taking every 2 second element. But we can take let me just clarify that. Let me just make sure it's correct. So yeah, it's used to specify how slicing operation can work. Yeah, so again, double column means every second or every however many things. So again, this is every second element. So we start at index 0, we jump, we skip 1. So the every second element we output. So it's 1 and 3. Yeah, so this is basically every second element. If you do semicolon 3, it'll output every third element. So it'll start from 1 and then output 1 and 4. So to add element to a list, use the append method. So if you do a list dot append for the value, it'll basically add this value into the end of the list. So now you have 1, 2, 3, 4. And to add a list of the end, use the extend method. So if you want to add a list, so instead of adding one number, you want to add a list, the 3 numbers at the same time. Instead of using append, you use extend, and then you will just get, if you want to extend the list with 4, 5, 6, you will just print out 1, 2, 3, 4, 5, 6. And then to remove elements, so this is also, so yeah, you'll be using the delete keyword, so del keyword, so short for delete. Basically you're deleting the L at index 1. So again, 0, 1, 2, this is the index. So index at 1 will be the number 2. So when we see that number 2 gets removed, we have 1 and 3 remaining in our list. And you can also delete a range of stuff. So again, our indexing. So 1, 2, 3 means basically the at index 1 and index 2. So we will delete B and C. We have AD left at the end. And you can also remove element by its value, so it will search for the value in that thing. So instead of instead of being delete, you actually call a function called remove. And so if you remove 2, in this case, you're not removing the index 2, you're removing the value 2. So this will also output 1 and 3. So it's different from last time where it's delete, this will be remove. So again, delete is for removing something at a specific index, whereas remove is removing that specific value. And again, you also use the length function, same with string. You can use the length function to output a length of this list. Changing the list value. So if you want to change in a specific value at a specific index of the list, all you have to do is you have to call that index. You have to use the assignment operator, equal sign, then you change the value. So again, the 0, 1, 2. So the thing at index 1 is banana. We're changing banana. We're replacing banana with black currant. So we've printed out. We have apple. We don't have banana, and instead of banana, we have this, and then we have cherry at the end. So again, this is basically called changing. We're changing the value of the list. Check if an item exists. So similar to string, we can use the end function. So we can check if something is in this list. So we have apple. So obviously we have apple in the list. So that means this will evaluate true, and then it will print out, yes, apple is in the fruits list. Sorting a list. So this is actually a bit more complicated, but for numbers at least, you can just do l.sort. And then this will basically give you a sorted list. So like how at the start we started from 2, 1, 3. So by default, it will sort from smallest to the biggest. So it'll have 1, 2, 3. To avoid modifying the original list, you can also use the sorted function. So basically what this does is it sorts the L, but without modifying whatever's in the original array, original list. So basically when we do print sorted L, we get our sorted list, which is 1, 2, 3. But if we print out just L again, you see that we actually didn't sort everything in our list. We actually completely didn't change it at all. This is because this is a temporary variable. It created another variable that's sorted, that has a sorted list, and it basically give you that output, but we didn't actually modify anything in the thing. So the difference is one is like l.sort. So it's a function that you put with a dot. One is sorted with the taking the function as an input. So how do you iterate through a list? Again, like how we iterated through a string, we can do our list by doing the range function with the length combined with the length function. So basically, in this case, same thing as a string, we'll just print out every single element in the fruits array, and then if we have the name Prad, same thing as so we already did this for the string back there. So we just print out the entire name one by one. So the output for this is still Prad, because yeah, we didn't put any spacing in it. We just like printed out the thing. So this entire thing is the same thing as just printing out the name straightforward. But yeah, same thing as the basically list is very similar to string because string is technically a list. It's a list of different characters combined together. For each loop. So instead of doing the complicated entire complicated thing with in range, length, blah blah blah, you can always just do for I and fruits. And then your I will be your each of the element in that list of stuff. So for I in fruits, it will print out every single thing. So we print out apple, banana, cherry. For I in name, the I will be P and an R and an A and D, and then it'll print them out individually. Why would you do that instead of just printing it? Yeah, so if you just print out the entire thing, if your goal is just to print out the entire thing, then you wouldn't really need to use it. But it's often useful in programming when you have to check specific letters. You have to check in like every single character in the thing. So like this, the printing wouldn't be a practical use case, but everything else is really useful when you have to iterate through the entire list or when you have to iterate through the entire word, basically. Pop. So the pop method remove the specified index. So basically, if you just pop at the end, so if you just pop, it will just basically just print out remove the index at the end. So remove cherry. So now your list will be apple and banana. The clear method empties the entire list. So if you do clear, you have an empty list. You have nothing in here. So this is like a literal just empty list. Don't print out nothing. Again, these are more convenient. These are like a lot more. These are just more convenient methods that you can may use. Reverse, basically just reverse the order of the elements. So instead of apple, banana, cherry, you will have cherry, apple, banana, or reverse. And the index method returns the position of the first occurrence of the specified value. So if you want to find out what index that this element the cherry is at, you just do a dot index bracket blah blah. So again, cherry is at our index 2, not 3, it's 2. So this will be x equals to 2. And what are functions? So functions is another part of very important part of coding. It's a set of statements that might take inputs. So again, might take inputs. So some functions do take inputs, some functions do not take inputs, but usually most functions takes inputs. So it basically does something and then can produce an output. So you're writing a separate program in itself in your entire program. So how do you define it? So you do def, so short for define, function name, so you have a parameter list, you have statements. So basically you have you have your name of a function, then you have your parameter list, which is basically what you want to take in as input. You can have multiple inputs, you can have like no inputs, you can have one input, you can have as many inputs as you want. And the statements is basically what it will do with the given input to produce output. The function name, your function name is used when you calling the function. So again, we advise you to use a function name that is like memorable or easy to understand, so that when you call the function, it's really easy for you to get back to it. The parameter list is used for information that needs to be passed into the function. So again, we're taking inputs, blah blah, statements that operations that occur. So yeah. Also, I'm going at a really fast pace because we're kind of running out of time. But if anyone has any clarifying questions, just put into the chat, and then I'll try to answer it. So why use functions? Functions are useful because oftentimes in code you have to perform a certain set of operation multiple times. So a function helps to reduce duplication in your code and breaks the code down into similar pieces. So if you have to do like a one operation like a lot of times, you can just use functions instead of like copying and repeating it many times. Number of parameters. By default, so when you have a function with 2 parameters, you have to call it with 2 parameters because basically yeah, if you have a function that requires 2 parameters, but then you only input 1 or you input 3, then the error will be thrown because the code does not know which elements is supposed like it knows that it does not have the correct number of inputs. Function and calling the function. So basically when you call a function, you would just do that. So if you have a function without any parameters, it'll just put out, you just have to leave a bracket at the end. So if a function returns something, that means you have to print it out manually at the end. But if your function prints out something automatically, then you just have to call it. So again, this is something that's more like complicated. You can the more you code, the more you understand it. But here is an example of a multiple parameter function. So size. So we're taking two parameters, x and y. So if x and y, if x bigger than y, we print out x is larger. If they're equal, we print out they're the same. If this at the end, we have y is larger. So notice how we have print in the function itself here. So we don't have to actually print out manually at the when we call the functions. So all I have to do with the call function 4, 7, which we can just put, oh, y is larger because we put in 4 and 7, and 7 is bigger than 4. So y is bigger than x, y is larger. And then size 5 and 5, we print out there it's the same because 5 is equals to 5. So it's a very simple multiple parameter function. And we'll be skipping the break because we're running out of time. And lastly, we will have the one last function. So the random module will allow us to generate random values in the computer and use them in our code. So we'll be making a hangman game really quickly. I'll be demonstrating how to make it from scratch. So we will have a word bank of hangman games and pick a word at random from the bank. Therefore, we need to use a random module to pick a random word. So this is something that's kind of like specialized because you don't usually use random a lot when you're writing code. But if you want to use some like a function, you can just always search it up. You can always search up on the internet, and then there'll always be code that or tutorials that tells you how to use a specific function. So how to accomplish a specific thing. So we'll use a randint function. So again, random.randint, which has two parameters and generates a number between those two parameters, inclusive. So this will not generate a 0 or a 10. It will generate a number between 0 and 10, a random integer between 0 and 10, but it will not generate 0 and 10. Sorry, it will generate 0 and 10. So it will generate any number from 0 to 10, basically. That's what inclusive means. So we'll now be making the game Hangman. So you can follow along in your own Repel. So if everyone can just open Replit. And let me just pause the screen share real quick because I need to get the source code out. How do you open Replit? So again, the website is replit.com or replit.id. So if you go into this website, just go to your browser, put in this URL, and then just create your account and then make a new file. It was actually a pretty straightforward game, relatively straightforward game, but I'll basically be going step by step. So we if everyone is ready, we will start now. So first of all, I'll just start by doing making the hang. So let's first of all, hangman. Obviously, we need a list of vocabulary. So list of words. So for this case, I have a library of 4 words. So we'll just start by initiating an array, initiating a list. So this is my list of basically all the possible words. It's pretty easy to guess, but for simplicity's sake, I'm just going to include 4 words. You can have as many as you want, but basically you'll start by having 4 words or however many words you want stored in a list. So again, how we initiate a list, remember how we use square brackets, and then we have commas in between. So this is how we do make a list. And then so at the beginning of the program, we have to obviously choose our targeted word. So we'll have our value word, or we can call it target if we want, because like just to not be confused with the word. And we'll be so we'll be choosing it randomly. So again, for the random function, we have to use the random module. So this is something that's more convenient that you have to like kind of just like memorize or like search on your own. But in order to use the random function, we have to import the random package. So there's something that's kind of more confusing, but basically just like a syntax thing you have to memorize. So we'll be using the random function, which picks out, so random int, which picks out any number from 0 to 4, right? Because the length of our word is 4. So words, so it'll be the length of the words function. But again, the random, if we do 0 to 4, it will actually output us 4 as well. But we don't want that because our indexing ends at 3. So if we do 4, it will be out of bounds. We have to do -1 here. So because so basically in our case, our length for the word is 4, but we have to do -1 because so we can get any number from 0 to 3. Again, it will generate 0, 1, 2, 3. So one of them, which matches 1, 0, 1, 2, 3 in our array. And also for the demonstration, if you have any questions at the end, if you have any questions in the middle, you can feel free to stop me at any time. So first of all, so now that we have our word, we have to take in inputs, right? We have to take in the input. So we have to have basically like a little UI design. So first of all, by the very start, what does your hangman look like? Your hangman looks like something like this. So if you have let's say a 6-letter word, you have 1, 2, 3, 4, 5, 6. You have 6 empty slots that you can put letters in. So we have to make that first. We'll be calling get string. So this is our guest string. And then we'll have this, but we don't know how many of these do we have. We don't know how many of these we have, right? We know that this should correspond to the number of letters in our word. So again, in Python, you can do something like this. Because basically, like, because the length of the word varies, right? With which word you end up getting. So basically, you have to make it so that it always adapt to that length. And then in Python, you can just do like this, multiply by this means that we will have this many of the underline. But at the end, obviously, you have to first off print out the guess string. So for now, let's run our program. So see right now we have our 6-letter word. So if you run it again, we have a 7-letter word. So which in this case should be library, which is pretty straightforward. But yeah, again, if we just run it multiple times, make sure that we're getting different results from time to time. So yeah, sometimes we're getting 7 words, sometimes we're getting this is the 8-letter word. So I think we're hitting all of our letters, all of our words, so it should be fine. So yeah. So basically, for our Hammond game, it's also useful to convert it into kind of to have like numbers to keep track of. Because how will you know if a game ends? A game ends when your guess string is equals to the targeted word, right? But it's a lot simpler if you can just convert that into a number. So basically, you can start with oh, you have 7 letters. And if you guess one letter correct, it'll become 6 remaining letters. So basically, we have a remaining letter number, which is should be the length of the target. So at the beginning, we will have like let's say if it's aquarium, we'll have 8 remaining letters to guess from. And then we can have so how many remaining guesses do you have? So we can let's say like let's say we can have 5 remaining guesses, right? Because let's just say because I guess hangman it's normally is the uh the 1, 2, 3, 4, 5, 6. Actually 6, sorry. So we have 6 remaining guesses because that's what hangman is. And then lastly, yeah, I guess this is enough for now. So basically what you want to do is so while you still have remaining letters, you still have letters remaining, that means you have to keep guessing, right? So while the remaining letters is bigger than zero, so while you still have letters to guess, um you'll be so basically you'll tell them, you'll ask the person to guess, right? So first of all you have to output first, oh, so these are the letters you guessed first. So we'll just first of all tell them what letters they've guessed. So again, we will be using the plus sign as to concatenate two strings um for guess bank. And sorry, I mean, we also have to keep track of our keep track of all the letters that they've guessed. So we'll be having an empty array, or an empty list that has all the letters that the person had to guess before. So at the beginning of each thing, because remember how we do hangman, we have let's say we have a like a three-letter word. If we guess A and it's not there, I mean we draw a head, but we show that they have guessed A already, so they don't have to duplicate guess. So we show them how many what are the letters that they guessed so far, and then we take it. Now we take in the input. So we say user guess equals to input. So we'll instruct them to guess a letter. And notice how for input over here we can actually put in something, a string that we can basically when we run this, it will say, oh, guess a letter. It'll tell you to guess a letter. So I'll tell you to guess a letter first, then it'll take the input. So basically this is basically saying it's what you're telling the user to do. So after we tell them to guess letter, we get our input a letter. We will check if the input is valid. So basically what we have to do here is we have to check, first of all, when we get a letter in, you have to check whether they've guessed the letter already, right? So um yeah, so basically whenever we're given input, we also have to check whether that input is correct or not. So for example, if we input like a number, like if we input a number, for example, I mean that obviously there's no word that contains a number, right? So that means that's an invalid input that we shouldn't deduct points off of them. And if it's not, if they already guessed that letter, so if that letter is in our guessed bank, that means that's also a valid input, so we shouldn't deduct a life out of them. So basically, in this case, we can use a function that says check invalid, that takes in a character. So basically, we'll be taking in a character to check whether something is valid or invalid. So first of all, if you input multiple characters, right? If you input some multiple characters, well, if you input something that's if you input like more than one characters, or if you input like a space or something, then it's obviously invalid. So we'll be returning true. So we'll say that it is invalid. Or if a character, so if it's not an alphabet value, so if there's a number or something. So again, character.isAlpha checks whether or not a number is is a part of alphabet. So if it's not a part of alphabet, so if it's false, then we will be also saying that's invalid. Or if we have already guessed the character, so if the character is in the guess bank, all of these conditions will lead to us saying that, oh, this is invalid, so we'll return true. So again, return true because we're saying this is invalid. Else, if it doesn't meet any of these, it will return false. So again, return function basically returns the output, tells it the output of the specific function. So for this case, we check invalid. So let's test our program real quick. So at the end, so let's just before I do the while loop. So let's check if some of them letters that we have are invalid or not. Let's say we have an A, which is obviously a valid number. We have like A, B, C. If we have like a letter, if we have a number, if we have something that's like a random symbol, any of these, we'll just check if any of these are valid or not. Oh, sorry, we have to print it out first. Sorry, because over here we returned it instead of we returned it instead of actually printing it out. So we just print it out saying that. Oh, what is our value? So we should get false, true, true, true. So this is not invalid, so that means it's false. And this, all of three of these are invalid, so that's why we got true here as output. So we know that now we've checked that, we know that our program actually is correct. So our function is running as intended. So we can go back to our game part of the problem. So if we check invalid, so if we check if the user's guess is invalid, that means we'll tell them to redo their guess, right? We'll just say print, say, oh, this guess is invalid because this is invalid. We don't have to say we don't have to say why. So we can say please try again. So at the end we have this backslash n, because this is a special operator that basically it's like a return. It's like a enter. It's like when you press enter on the keyboard, it'll go on to the next line. So it will just basically go on to the next line at the end of a program. So what else should we do in our if statement? So if we already guessed, we'll just send them back to the front, right? We have to send them back to go through this entire step again. So we'll just put continue. So as we learned last time, continue basically just skips everything after the iteration and I'll go back into the while loop from the top again. So this basically checks whether our input is valid. So basically past this point, we know that all of our input is valid. So we have a valid input. So what do you do when you have a valid input? First of all, for Hangman, they might input, first of all, bug fixing, right? They might have uppercase or lowercase letters. So if we want to unify everything, we can put everything into lowercase. We'll do user guess lower. And we'll try to find if our letters is inside if the letters is inside our program. So yeah. So basically we'll try to find if our if the guess is a part of a letter. Sorry, a part of a word. Okay, if you have to get going, feel free to just leave any time. Sorry, I'm just kind of running out of time. The slides will be posted at the end of a class, and we'll also have the link to the Hangman game. So if you want to look at it after class, you can just take a look at that. But yeah, basically you have to check whether or not that letter is inside that word. So if the user guess is inside our targeted word, that means that we have successfully guessed a letter, right? So so basically we'll do some over here, but if it's not inside our targeted word, it should be indented like this. So first of all, let's kind of do the part where it's not in a targeted word. So if it's not in a targeted word, that means we lost the guess. So we guessed remain minus equals to 1. And then we have to add in our newest we have to keep track of the guesses that the person has done. So we guess bank dot append user guess. And now we have to tell them that they have incorrectly guessed the number. So we put user guess plus is not in the word. Right. So And then after we check this the guess remain thing, if they at the end if they have no more guesses, we also have to check if guess remain goes to 0. If they have no more guesses, then we have to say that oh you lost. We'll just give a little sad face. And I mean, obviously we have to tell them what the actual word is, right? So we have to say your word, the word was actually plus word, plus target, because this is our target value. And then at the end, we have to break the code. So this is the most important part because we'll be breaking from the while loop. We will not be going back into the while loop again. So that means our game ends here. So that means that's why I have to break into the thing. So that's basically how you would do the else part of the statement. So, but if we correctly guess is our input, right? So again, let me just, this is like incorrect. Yes. So this is correct. Yes. So if we get a correct, correct. So if we get the correct guess, that means we say, oh, you have gotten the correct guess. Um, actually, sorry, I haven't finished with the incorrect guesses yet. So if you still have guesses remains, that means we have to tell them how many guesses you have remain, right? So you have plus uh yes remain. So you have this many guesses remaining. Well, this might not be, it might be guesses. So why we have to the reason why we have to change this into a string here is because we're combining different string. We're combining a number with a string. So we have to cast it into a string first, then we can actually get the result out. So at the end, if they have more tries, that means we have to print out our guessed input. So our what is it? Remaining sorry the get string. So this again the get string is our like the underline thing. So again our get string is like the again the our 5 lines or 6 lines that we have. Let me continue. So that's basically all we have to do for incorrect guess. But if it's a correct guess, then we have to do something. So we will print. We're saying congratulations. So it was nice. The user guess. Oh, I forgot about this. We'll say the user guess is in the word. Um. So yeah, we will say that oh the user guess is in the word. Congratulations. And now, so basically a hangman in the game of hangman, if our target word is let's say robot. If we guess O, you have to replace this. You have to replace all occurrences of O over here. So we have to say that oh, both of these are O, right? So what basically for this we have to do a for loop. Have to iterate through the word to replace any occurrences of that letter. So basically, first of all, we have to obviously keep track of our guest bank. Right. Yeah, so we have to keep track of our guest bank. So first of all, we have to do the guest bank and our user guest. And again, you can see here, for this is actually something called like design for the software design. So we see that we have a duplicate code here. So no matter if it goes into the if statement or not, it will be doing a guess. We'll be adding the guess into our guess bank. So we actually don't need this in our if statements. We'll just put them at the very beginning because I mean obviously it'll be in our guess bank. Um, user guess, not in the word. User guess, user guess, user guess. So we print out, oh, hooray, nice, you got the words. Now all you have to do is you have to replace every single like appearance in that guess string. So you have to print out every single appearance. You have to replace every single appearance of that letter inside that word with the correct letter. So all I have to do here is if we iterate through the entire list, so we'll do for letter in the target, sorry, in target, yeah, in target. And so if the letter equals to the target, sorry, if the letter equals to the user guess, what you have to do is you have to replace that specific place at thing. So actually it will be easier if you do in range of lang target. So if the target at x is equal to the user guess, that means we have to replace that means we have correctly gotten one letter. So we'll do get string, add that letter, becomes the user guess. Or becomes the user guess. And then we'll have to update our remaining letters to make sure that minus equals to 1. And then yeah, that should be it for this part. So at the end of the for loop, after we're done with the for loop, we just print out our guess string again. And is there anything else? And at the very end, at the very end, basically, to tell them whether or not they have won, you have to do if remaining if guess remaining is bigger than 0, then you've won. So it turns out congratulations. Win. So we run our code. So let's say we guess our letter A. Oh, we got run the output. Oh, sorry, guess string. Oh, sorry. So for guess for strings, you actually cannot replace it like this. So you have to do it the hard way. So you have to get string equals to from 0 to that x index plus the user guess plus guess string from the x plus 1 the end. So again, this is a complicated thing. So basically we start from index 0. We end at index x because we don't want the letter at index x. We actually want everything before that. And then we will want our user, to replace with our user guess. Then we will want to start from the x plus 1 index and then go all the way to the end. So right now, if we do it again, so if we guess the letter A, we say, oh, A isn't a word. So let's say we guess letter E. Oh, E is not in the word. It's not in the word. Okay. So we put, let's say if we get something like A again, oh, it doesn't matter. Try again. E again, because it's already in there. So if we guess it's like a bunch of random stuff, it will not be in there. So if we guess I, we say I isn't a word. But at this point, if we look at our bank, we know that the word is library. So just put library. And notice how if we put R, we actually get both of the R's. So this means that our program is running correctly. So we put Y, we see that, oh, congratulations, you've won. Y. So nice, and Y isn't a word. So we won the entire thing. We get our library word. But how about if we fail? Let's make sure that we can actually fail. So I just put in a bunch of random words, random letters. So this is our last guess. And we see that we have lost our tries. The word was actually tables. We just run it one more time. Let's say we have, so this is spider, so we just get a spider, and we see that spider is running. So that means our program is running. So that's basically how you would do how you make a hangman game from start to finish. And yeah, that's basically the end of our lesson. Feel free to reach out if you have any questions, and yeah, hopefully to see you guys in the future.